Riddle me this, mother lecker.
Here's a fun problem I saw online. What is the integral from 0 to 1 of -1 raised to the power of x equal to? Solve using the principal value. Pause if you'd like to give this problem a try, and when you're ready keep watching to learn how to solve this problem. We'll get started with Euler's formula that e to the I theta is equal to the cosine of theta plus I times the sine of theta. We substitute theta is equal to pi and then we simplify to get e to the I pi is equal to -1. Now we have to be a little bit careful here because that's not the only way that we can get -1. There are also other ways that you could get -1. But we'll focus on the principal value. We're now going to raise both sides to the power of x. We can then use the rules of exponents imply the right-hand side. We're now ready to evaluate our integral. We substitute in what we just arrived in. Now we need to take this integral of v to the power of I times pi times x. This is routine, it'll be e to the I pi x all over I times pi. And we want to evaluate this from 0 to 1. So we substitute those in and now we're going to simplify. E to the I pi is equal to -1 and then we combine these fractions. We could then simplify this a little bit more. We multiply the numerator and denominator by I, and since I squared is equal to -1 this all simplifies to be 2I all over pi. So it's pretty interesting. We started out with this fairly routine integral and we ended up with I and pi in the answer. Amazing.
Riddle me this, mother lecker.